This is Shram Academy. Question number 9, page 27 for the Alkenes and Alkynes homework. Let's rock. Alright, so first instruction, write chemical equations using condensed structural formulas to represent the addition reactions that produce the following compounds. Include the names of the reactants. So, quick little side note here, addition reactions. Okay, we've got hydrogenation. And that's where we're adding hydrogen. We've got halogenation. That's where you're adding one of the halogen molecules or elements. We've got hydrohalogenation. And that's where we're adding an acid halide, hydrogen chloride, hydrogen bromide, etc. And finally, we've got hydration. Now I'm just going to draw this one in red. Just so it stands out a bit. Now, when we're adding water, I want you to think of water like HOH. Okay, now I've written that linear, and that's not really sort of geometrically accurate, but that's okay for now. So addition. We're adding water. Okay, so the H is going to go on one carbon, and the OH is going on the other. And again, that harkens back to Markov-Nikov's rule, which we'll get into. Alright, so what we need to do is remember then the products of each of these. And that's in our note, our main note. So hydrogenation, we're going to convert an alkene into an alkane. For hydrogenation, we're going to convert an alkene into, an alkene into an alkyl dihalide. For hydrohalogenation, we're just going to make an alkyl halide. And hydration, we're going to make an alcohol. Now, as far as the alcohols go, I will put the names, but I wouldn't expect you to know how to do alcoholic nomenclature because I haven't taught that yet. Okay, so it's like a little preview of things to come. So let's rock and roll here. So if we're talking about 2,3-dichlorobutane, that's an alkyl dihalide. So that's a halogenation reaction. Okay. So here we go. Condensed formulas. CH3. Carbon 2 has the double bond to carbon 3. And there's carbon 4. Plus. Sorry about that. Cl2. And so what's going to happen, what I'll do is I'm going to draw what's called the transition complex, okay? So this is before a reaction. And Rx is short form for reaction. This is during. So what's going to happen, I'll just show you with these guys, okay? So I'm going to do sort of semi-condensed. So we've got an H there. Whoops, that double bond is going to actually break open. And that creates what's called a free radical, where that electron here and that electron there is going to basically be free to now bond. Okay? And we'll just slap that guy in there, it doesn't matter. And what's happened is the chlorine molecule is now split into 2 chlorine atoms. And as we remember from grade 9 or 10 or 11, chlorine has 7 valence electrons. And so what's going to happen is this covalent bond here is going to form. because those electrons are going to share. Okay. And we're just going to move it over here for the product. 2,3-dichlorobutane. And we can recondense it. And although I'm doing mine in color, you don't have to, but I like it because it gives me pause, and it's a little bit more visually appealing, I think. Okay. So halogenation is a particular kind of reaction. Now, this one's interesting. Markovnikov's rule, we'll check it out. Let's see what it says. Now, this might not be the only product that might occur in this case, so I'm just going to draw this sucker out and we'll back engineer it, okay? Maybe move down a bit. 3-bromohexane is our product. One, 2, 3, 4, 5, 6. Okay, and we'll put a bromine on there. Now, where could this have come from? We got a couple possible reactants here. Since we're dealing with an alkyl halide, then we know this is actually a hydrohalogenation. So bromine had to be added. Now, this is where this dude Markovnikov comes in. And it's not necessarily the only product. However, the question, as it asks, right, is what will produce it? Okay, so where could this come from? What reactants could generate this thing? Well, let's back engineer this then. Okay, so I'm going to go HBr. Now I'm just going to keep the H's black because it's a bit of a headache to draw it the other way. So we're adding HBr. Okay, but what are our options? Well, let's play with this a bit. So CH3, so we definitely know that CH, that the third carbon has to be involved in the double bond. Okay, so this is possible here. 1, 2, 3, 4, 5, 6. So hex 2ene plus hydrobromic acid or hydrogen bromide, or is there another possibility here that could lead to the same thing? What if we did this? So 1, 2, 3, 4, 5, and 6. Check it out. Oops, one little error, very important. There needs to be an H there. Okay, so carbon 2 and carbon 3 in this case, neither are richer, so it's possible for that bromine to go on either of them from the HBr based on Markovnikov's rule. So it's a 50-50 probability that that would land there. Okay, we do know that the bromine has to land on carbon number 3, so is it not possible to go 1, 2, 3, 4, 5, and 6. Okay? But here's the deal. If you look closely, actually, no, this works. The bromine could go on to carbon 3 in this case, because 3 and 4 both have the same number of hydrogens. So the hydrogen of hydrogen bromide could go on to those equally. And I'm still naming it under the system I learned. So hex 3-ene is the other option. Okay, and I think we had to name this one here too, up top. So this came from but-2-ene. Okay, so again, 3 and 4, the equal probability of this hydrogen, of the hydrogen bromide, landing on either carbon 3 or carbon 4. And either case could get us there, okay? Or carbon 2 and carbon 3 in the case of hex 2-ene. And that's question 9.